March 2019, paper 4, variant 2. Question 1, define acceleration. What is acceleration? It is the rate of change of velocity. Rate of change of velocity. In question B, you have the distance time graph. Describe the motion from 0 to 15. This is a distance time graph. From 0 to 15, it's curving upwards, so the speed increases. Speed increases, or it is accelerating. Yes. From 15 to 30, this is a constant slope. So we have a constant speed. Constant speed. From 30 to 40, what's happening to the speed? The speed is decreasing. Why? Because it's curving downwards. So speed decreases, or you can say deceleration. Calculate for the 40-second journey the average speed. Can I find the average speed? Total distance over total time. Total distance was 300 and total time was 40. Okay. Equals total distance over total time, which is 300 over 40. 340 is 7.5 meters per second. Can I find the maximum speed? Yes, I can find the maximum speed, which is the speed in the straight section. Speed in this straight section. So this point was 20 and 130. Okay. 20 and isn't this 130? Yes, 20 and 130. And this point is 30 with 250. 250 minus 130 over 30 minus 20. Over 30 minus 20. Yes, this is 120 over 10, 12 meters per second. 12 meters per second. State one advantage and one disadvantage of using a wind turbine as a source of electrical energy. One advantage, it is renewable. One disadvantage, you can say that it causes noise pollution. Noise pollution. You have a wind turbine, the speed of the wind is 16 meters per second. The wind blows at the speed of 16 meters per second. In 1 second, a volume of 24,000 meters cubed of air passes. The density of the air is 1.3 kilograms per meter cubed. Can I find the mass of the air passing each second? Yes, I can find the mass. Density equals mass over volume, therefore mass equals density times volume, which is 1.3 times 24,000. What's 1.3 times 24,000? This is 31,200 kilograms. 31,200 kilograms. Kinetic energy. Can I find the kinetic energy? Yes, half mv squared. So half times 31,200 times the velocity squared, which is 16 squared. This would be a huge number. Yes, definitely a huge number. Half times 31,200 times 16 squared, 3,990,000. So it's basically 4 million, or 4 times 10 to the power of 6. 4 times 10 to the power of 6 joules. Suggests why some of the kinetic energy that passes through the circular area is not converted into electrical energy. Again, you'd say that some of the energy is lost, okay, to the surroundings due to the, let's say, friction. Okay, due to the friction of the energy is lost to the surroundings due to friction. Okay. An object is moving in a straight line at a constant speed. State three ways in which a force may change the motion of an object. How can a force change the motion of the object? It can change the direction, right? It can change the speed, okay? It can change the acceleration itself, right? Okay, can change the direction, can change the speed, and can also change the acceleration. Figure 3.1 is cancelled. This part of the question is cancelled. Why? Because you're not required to find, okay, the resultant if it's not exactly 90 degrees. This part is also cancelled. Okay, you're not required to find the barometer. Okay, this is all cancelled. This is all cancelled. So you are actually in luck today. Again, we're talking about thermometers, which is also cancelled. This is a really, it says your lucky day today. So this is all cancelled. Okay. Hmm. Again, thermocouple has been removed. I think this might be the easiest test yet. Right. Okay. And okay, state the main process by which the thermal energy is transferred to the air in all parts of the room if you have an electrical heater inside the room. The main, what is the main process? It's by convection. It is by convection. Now, we have heater, power of the heater, the mass of the air, the specific heat capacity. Okay, calculate the time it takes for the heater to raise the temperature from 8 to 15 degrees Celsius. Can I find the energy first? Yes, I can find the energy first. MC delta T, what is the mass of the air? 65. What is the C? 720. We don't need to convert anything. Delta T is from 8 to 15, basically 15 minus 8, which is 7. So what's this? 65 times 720 times 7, 32,600. 327,000, sorry, 327,600 joules. You have the power, which is 1.5 kilowatts. So you need to multiply it by 1,000. So power equals energy over time. Therefore, the time would be equal to the energy over the power. 327,600 divided by the power, which is 1,500. Okay, divided by, this would be 218 seconds. 218 seconds. State two reasons why the time calculated is smaller than the actual time taken to raise the temperature of the air. Two reasons. Might be what? Might be some of the energy is lost to the surroundings. Yes, it is lost to the surroundings, but in this question, you might need to be a bit more specific as to which surroundings exactly. Which surroundings exactly. So you might say, for example, the heat is used to raise the temperature of the furniture around you. Okay, you might say some of the heat or some of the air escapes through small cracks in the windows and the doors. It is correct, right? Some, okay, air escapes through cracks in the windows and door. Some of the heat, okay, some of the heat is used to increase the temperature of the furniture. Okay, X and Y from solid to liquid. Y from liquid to gas. Explain in terms of their forces between the molecules why gases expand more than solids when they undergo. Why do they expand more than solids? Because of their almost non-existent forces due to the very weak forces. Okay, very weak forces between molecules, very weak intermolecular forces. You can also talk about the distances between the molecules. Okay, gases have large distances between the molecules. A cylinder of volume 0.012 contains a compressed gas of pressure 1.8 times 10 to the power of 6. A valve is opened and all of the compressed gas escapes from the cylinder into the atmosphere. Calculate the volume that the escaped gas occupies at the atmospheric pressure of 1 times 10 to the power of 5 pascals. Okay, what should I do? P1 V1 equals P2 V2. P1 V1 equals what? P2 V2. You have the initial pressure, which is 1.8 times 10 to the power of 6. And then you have the initial volume, which is 0.012, the volume of the cylinder. Then pressure 2 is 1 times 10 to the power of 5. Can I find V2? Yes, I can find V2. Divide this by 1 times 10 to the power of 5. Okay, so 1.8 times 10 to the power of 6 times 0.012 divided by 1 times 10 to the power of 5. This is 0.216. So V2 is now equal to 0.216. This is not the final answer. Why is this not the final answer? Because this is the volume of the air that has escaped plus the volume of the cylinder. You need to subtract to find the volume. It would be 0.216 minus 0.012. You have to subtract the initial volume minus 0.012. This will give you a volume of 0.204 meters cubed. This is the final volume of the air. Okay. Figure 8.1 shows parallel wave fronts and ice. The speed of the light wave is 3 times 10 to the power of 8. Refractive index is 1.3. On figure 8.1, draw the wave fronts that have passed into the air. It's moving from ice into air. Draw the arrow. Okay, let's show the angle of incidence, angle of refraction, everything. First of all, you have to continue this line. And then at this point, draw a normal line. So this is the normal. As you're moving from ice to air, will the ray get bent towards the normal or away from the normal? Will the angle increase or decrease? Yes, the angle will increase. Why will it increase? Why will it increase? Because it's moving into air, so the speed increases. It's moving away this way. This is direction. So it's moving away from this way. So this is the direction. This is the angle of incidence, and this is the angle of refraction. Can I draw wave fronts that have moved into the air? Yes, I can draw the wave fronts, which would be in this direction. Okay, the wave fronts would be bent away, meaning that the angle would increase. The wavelength would increase. The speed increases, the wavelength increases. They all increase as it moves into the air. Can I find the speed of light in the ice? Yes, I can find the speed. So actually, n equals speed of light in air over speed of light in the medium. Speed of light in the medium is equal to VA over N. 3 times 10 to the power of 8 over 1.3. 3 times 10 to the power of 8 over 1.3, which is what? 2.3 times 10 to the power of 2.3 times 10 to the power of 8 meters per second. Figure 9.1 shows the current potential difference graphs for a resistor and a thermistor. Calculate the resistance of the thermistor. Calculate the resistance of the thermistor when the potential difference across it is 7 volts. At 7 volts, I can draw a line, okay, giving me a current of what? A current of, yes, 0.46, right? This will give you a current of 0.4, or I'm sorry, 4.6. So R equals V over I, 4.6. 7 divided by 4.6. What's 7 divided by 4.6? 1.5 ohms. 1.5 ohms. In table 9.1, tick the boxes that indicate the effect on the resistance of the resistor and the thermistor. As the resistance or as the voltage increases from 0 to 7. As the voltage increases from 0 to 7, what happens to the resistance of the thermistor, for example, or of the resistor? The thermistor is curving upwards, right? The thermistor is curving upwards, and the resistor is moving in a straight line. So the resistance of the resistor, is constant, right? While the resistance of the thermistor, what's happening to the resistance of the thermistor? It's decreasing. Why is it decreasing? Because when it curves towards the current axis, current axis, what happens to resistance? Decreases. If it was curving the other way, towards the voltage axis, then the resistance would have increased. Thermistor and the resistor are connected in parallel to a 7-volt supply. Calculate the current from the supply. They are both connected in what? In parallel to a 7-volt supply. Basically, they both have the same voltage. They both have the same what? The same voltage. Can I draw a simple circuit? Yes, just to show you have the supply, you have the thermistor. This is the resistor, for example, and then the other one is the thermistor. They both have what? They both have 7 volts. This is 7 volts and this is 7 volts. Can I find the total current of this circuit? Yes, from the graph. From the graph. We said that the thermistor would have a current of 4.6. At 7 volts, the resistor would also have a current of 4.6 amperes. They would both have a current of 4. This is just pure luck. Again, this is just pure luck. For example, if the voltage was 4 volts, I'm just saying, if the voltage was 4 volts, the thermistor would have had a current of 1.5, and the resistor would have had a current of 2.6. So you would have added these currents, 1.5 and 2.6, but for 7 volts, again, this is pure luck. The current is 4.6 for the resistor and the current is 4.6 for the thermistor. We need to just add them up. 4.6 plus 4.6, which is 9.2 amperes. Can I find the energy transferred? Yes, I can find the energy transferred. Energy equals VIT. The voltage is 7 and the current is 9.2. The time is 5 minutes. You have to multiply it by 60 seconds. Okay. What's 7 times 9.2 times 5 times 60? This is 19,000 joules. So 1.9 times 10 to the power of 4 joules. electrical energy produced by a power station is transmitted over long distances at very high voltage. Explain why a high voltage is used. Explain why the high voltage is used. As voltage increases, what happens to current? Current decreases. Therefore, the energy lost, okay, due to heat decreases. Also, the power loss decreases. Power lost decreases. Why? Power loss decreases because power equals I squared R. I squared R. And last but not least, you can say you can use, okay, you can use thinner wires. Can use thinner wires. The advantages of increasing the voltage. Okay. Now we have a transformer. Primary coil has 4,000 turns, input of 120 volts. Secondary coil has an output of 9 volts. Can I find the number? Yes. VP over NP equals VS over NS. 120 over 4,000 equals VS, which is 9 over NS. Cross multiplication, 4,000 times 9 divided by 120. 300, you have 300 turns, right? You have 300 turns. Suitable material for the core, iron or soft iron. One isotope is represented by 77, 194. It produces platinum, right? And a beta. Beta is 0 and -1. So the mass would be 194, but the proton number would increase by 1. So this would be 78. It has to be 78. Okay. Half-life of iridium is 19 hours. A sample has an initial count rate of 1,100 counts. We need to find the sample after 38 hours. You don't have any background radiation. So basically you have to say that 38 divided by 19 is what? Is 2. What does 2 represent? It represents 2 half lives, meaning that we have to divide this number 1,100 divide by 2 times. 550 divide by 2 again. This is 275, right? 275 counts per minute. State 2 ways in which gamma radiation differs from beta emission. That's simple. Gamma radiation is an electromagnetic wave, right? Gamma is an electromagnetic wave. You can say that beta is an electron. You can say that gamma has no mass, right? You can say that gamma is uncharged. Gamma is uncharged. Beta is negatively charged, right? So you have several differences. You have several differences. Okay.